This video is a solution guide for the lesson 6-1 homework assignment. It's from page 248 and it's numbers 9 through 27 odd. The directions are to simplify the fraction and identify any restrictions. Make sure that you show work. All right, in our presentation yesterday, we learned that it's a three-step process to simplify an algebraic fraction. Step 1, factor the numerator and the denominator if they are not already in factored form. Step 2, cancel with slash marks common factors top and bottom. Step 3, write the answer and give restricted values. In the day 1 assignment, there were several students that submitted their paper. They gave simplest form but did not remember to include the restricted values. So pay attention to that this second time through. Now, how do you find the restricted values? You examine the denominator of the original fraction and identify values that would make the denominator equal to 0. Here's number 9. The fraction is 2xy divided by x squared y minus y squared x. Let's run through the three-step process. First, make sure top and bottom are in factored form. The numerator is the monomial 2xy. Because it's a monomial, it cannot be factored. The denominator is a binomial. It has two terms, and there is a GCF. The GCF includes x and y. When you factor out GCF, you follow that with one set of parentheses. xy times x is the x squared y term, and xy times minus y is the y squared x term. The second step is the canceling. There is an x in the top and an x in the bottom. There's a y in the top and a y in the bottom. That's all of the canceling. Now we're going to write the simplest form. The numerator is 2, and the denominator is the factor x minus y. There's no need to put parentheses around that because the x and y canceled away with nothing else down in the bottom. You don't need parentheses around the x minus y. Now there are going to be restrictions. You need to indicate any values that cannot be used for x or y. The way that that is done is to look at the original denominator and to indicate that that cannot be equal to 0. So for the restrictions, you write x squared y minus y squared x, that's the original denominator, and indicate that you realize that that cannot be equal to 0. Now I said that I write the original denominator down and say it can't be equal to 0. But really what I want is the factored form of the original denominator. And that's the xy, parenthesis, x minus y. And I want to say that that cannot be equal to 0. It's always easier to work with factored form than it is with polynomial form. That's one reason why we put all the effort into learning how to factor. Now we're going to individually look at each factor and indicate that they cannot be equal to 0. The first factor is x, so you say x cannot be equal to 0. The second factor is the letter y, so you say y cannot be equal to 0. The third factor is x minus y. That cannot be equal to 0. And if you add y to both sides, you end up getting that x cannot be equal to y. These three statements are the restricted values. So on the right side of the screen, I'm going to give the final answer. It is 2 over x minus y. Then you write a comma and you put the restricted values. X cannot be equal to 0. Y cannot be equal to 0. And the x cannot be the same number as the y. Here's the answer in the box. Problem 11. Problem 11 is going to be a lot faster because the numerator and the denominator are already in factored form, and because the denominator only has one variable in it, it's not going to be as confusing as the one we just did when we get the restrictions. Step 1 is already done. Top and bottom are factored. Step 2 is to cancel out common factors. You need to realize that 2x plus 1 is really the same thing as 1 plus 2x. Addition is commutative. Those are equal expressions. The result is x plus 4 in the numerator and x minus 3 in the denominator. Now we're going to get the restrictions. The denominator cannot be equal to 0. So I look at the original problem, and the denominator is 1 plus 2x times x minus 3, and I want to state that that can't be 0. Now that's already in factored form, so using the zero product property, we know that we examine each factor and list that each factor cannot be equal to 0. Solving the first, by subtracting 1 and then dividing by 2, we get negative 1/2. Solving the second, by adding 3 to both sides, we get a 3. Now over on the right side, I'm going to write the final answer. It's x plus 4 divided by x minus 3, comma, with the restrictions that x cannot be equal to negative 1 or 3. Okay, problem 13. Simplify the expression. Step 1 is to factor. The numerator is a perfect square trinomial, so it factors as a plus 4 squared. The denominator is a difference of squares, but written in the wrong order. So the first step is to factor out a negative, which allows us to reverse the order of the subtraction to create that difference of squares. Next, I'm going to keep the denominator the same. The numerator the same. And then in the denominator, factor the difference of squares. Step 2 is canceling. The a plus 4 factor in the bottom can cancel one of the a plus 4 factors, leaving one remaining. The simplified form has a plus 4 in the top, and in the bottom there's a negative a minus 4. Now the restrictions. Go back to the original denominator, the 16 minus a squared, and indicate that you realize that that cannot be 0. And think about for what values of a that would be 0. Remember that we had already factored this, getting negative a plus 4 times a minus 4. In the next step, you can divide both sides by negative 1, which eliminates the negative sign at the beginning. Now we can examine both factors separately. The a plus 4 cannot be equal to 0, or the a minus 4 cannot be equal to 0. In the first case, a cannot be equal to negative 4, and in the second case, a cannot be equal to positive 4. Now I want to write the answer to this problem, including the restricted values. And I'll do that right up here. A plus 4 over the negative of a minus 4, comma, a cannot equal positive or negative 4. I was tight on room, so I used the plus minus symbol to indicate both of the restricted values. Next, number 15. Step 1 is to factor. Please notice that the numerator is not in the right order. So I'm going to factor it by factoring out a negative sign, which allows me to reverse the order of the subtraction. Now the denominator is a trinomial, but it's a special kind called a perfect square trinomial. It's going to factor as y minus 2 squared. Next is the canceling. The y minus 2 in the top can cancel one of the y minus 2 factors in the bottom, leaving 1 remaining. The final answer has a negative sign, and there has to be some number in the top to hold that position as the numerator. It's going to be a 1. When something is canceled out completely, but you need something there to hold that position, you use a 1. And in the denominator, it's y minus 2. Now the restricted values. You go back to the original denominator. Y squared minus 4y plus 4 cannot be equal to 0. Remember that we had already factored that as y minus 2 squared, so that cannot be equal to 0. Think about what y minus 2 squared means. It means you have identical factors. Y minus 2 times y minus 2, and that cannot be equal to 0. Now, what is the value of y that is restricted? Y cannot be equal to 2. So over here on the right, I'm going to write the answer to the problem. It's negative 1 over y minus 2, comma, and the restriction is that y cannot be equal to 2. Next, number 17. The first step is to factor. There's a GCF of 4. After you write the GCF, you put one set of parentheses. 4 times n squared is the 4n squared. Now, 4 times what makes 144? So I'm going to take a calculator and go 144 divided by 4 to figure out what that number is. It's 36. Now in the denominator, there's a GCF of 6. And then in the parentheses is n plus 6. Now the canceling, or in this case, you might even refer to it as reducing, because there's a coefficient of 4 and a coefficient of 6. They don't completely cancel, but they do reduce. 4 and 6 both divide by 2. 4 divided by 2 makes 2, and 6 divided by 2 makes a 3. So the final result has a 2, and then n squared plus 36. In the denominator, there's a 3, and there's an n plus 6. All right, now the restriction. Go back to the original denominator, the 6n plus 36, and indicate that that cannot be equal to 0. And now solve this expression. You could subtract 36 from both sides, getting 6n cannot be equal to negative 36, and then divide both sides by 6, finding out that n cannot be equal to negative 6. Final answer is 2 parentheses n squared plus 36 over 3 parentheses n plus 6, comma, and then indicate the restricted value. N cannot be equal to negative 6. All right, number 19. The first step is to factor the trinomial. 2n times n is the 2n squared. Now to get negative 3, it's got to involve a 3 and a 1, and one of them must be positive and one must be negative. I'm going to put the negative 3 here and the positive 1 here. The reason for that is that the outer product makes negative 6n, and the inner product makes positive 1n, and adding together is negative 5n, and that's what's in the middle. Now the denominator, let's factor this trinomial. To make 4n squared, it's either 4n times n, or it's 2n times 2n. I'm going to go with 2n times 2n and see if this works. To make negative 5, it's got to be 5 times 1. One of them is negative and one of them is positive. I'm going to put the negative 5 here and the positive 1 here. And the reason for doing that is that the outer product is 2n, and the inner product is negative 10n, and combining these together is negative 8n, and that's what's in the middle. Next step, cancel common factors. The 2n plus 1 factor cancels the 2n plus 1 factor. The result is n minus 3 on the top and 2n minus 5 on the bottom. Now the restrictions. Remember that you use the original denominator and say that it can't be equal to 0. However, we're actually going to want the factored form of the original denominator. So I'm going to stop writing the original denominator when I already know its factored form, right? So if I just directly write the factored form and say that it cannot be equal to 0, this is going to save me a little bit of writing. This means that the 2n minus 5 cannot be equal to 0, or that the 2n plus 1 cannot be equal to 0. Adding 5 and dividing by 2, you get 5 over 2. Subtracting 1 and dividing by 2, you get negative 1 over 2. Now I'm going to write the final answer on the right. N minus 3 over 2n minus 5, comma, with the restriction that n cannot be equal to 5 halves, or that n cannot be equal to negative 1 half. Now number 21, simplify the fraction. The first thing you do is you put it in factored form. The GCF of the top is 3x. 3x times x is 3x squared. 3x times 2 is 6x. Now in the denominator, it's a trinomial, so if it factors, it will be 2 sets of parentheses. I need something that multiplies together to make 6x squared. It could be 3x times 2x, or it could be 6x times 1x. Now, thinking ahead, if something's going to cancel out with the red slash marks, then there has to be matching factors top and bottom. If I start it with 3x and 2x, it's not going to end up making anything that's going to match the top. That could happen, but it's more likely that the textbook authors wrote a problem that actually will have some canceling. So I'm thinking that their intention is for me to factor it using 6x times 1x. Now I need two numbers that multiply together to make negative 10. It could be a 1 and a 10, or a 2 and a 5. I think it's probably got to be the 2 and the 5, or else I'm not going to get anything to match up in the top. In fact, this probably needs to be a plus 2 here and a minus 5 here so that I get those matching x plus 2 factors. Now let's check out and see if this works. The outer product is 12x, and the inner product is negative 5x, and combining these together is 7x, and that is what's in the middle. So I was using the fact that the authors probably wrote the problem in a certain way that it would work out nicely to help me do the factoring. Next, cancel. X plus 2 and x plus 2. There's a 3x left in the top, and in the bottom a 6x minus 5. All right, now the restrictions. Again, it goes back to the original denominator, but really, I'd rather have the factored form of that denominator. So the 6x minus 5 and the x plus 2. That cannot be equal to 0. Next, I want to separately examine both of those factors to see what the restricted value is. If I add 5 and divide by 6, I'll find out that x cannot be equal to 5 over 6. And in this one, I find out that x cannot be equal to negative 2. Again, I'm skipping a step of writing. Right in the previous problem, problem 19, I had taken the time to write out this step here, whereas in problem 21, I'm getting to the same conclusion, but skipping a step of writing. The final answer is 3x on top, 6x minus 5 on the bottom, now a comma, and list the restricted values. X cannot be equal to 5 over 6 or -2. Problem 23. I want to factor the numerator. I notice that it's a trinomial, but it's not written in the correct order. So I first want to write the -a squared, then the -3a, and then the +10. In the denominator, I'm going to leave it as a squared minus 4. Now I notice that there is a negative leading coefficient. So I want to factor out the negative. And in the denominator, I'm going to leave it as a squared minus 4. Next step, factor the trinomial. A times a and +5 times -2. In the bottom, the a squared minus 4 factors as a plus 2, a minus 2. Now the canceling, the a minus 2 and the a minus 2. The result is negative, parenthesis, a plus 5 over a plus 2. Now I want to give the restricted values. The original denominator is a squared minus 4, but really I want to use the factored form of that denominator when I find my restricted values. So a squared minus 4 is the same thing as that a plus 2, a minus 2, which we had already figured out. Now separately examine each of these factors. In the first factor, we discover that a cannot be equal to -2, and in the second factor, we discover that a cannot be equal to +2. I'm going to go back up to where I had started to write my answer, put a comma by it, and then include the restriction a cannot be equal to positive or -2. Number 25, the top has a GCF of x. And then in parentheses, it's x plus y. The bottom also has the same GCF, x, but this time in parentheses, it's x minus y. Now the canceling. X cancels x. And the final result is x plus y over x minus y. Okay, now we're going to do the restrictions. Write down the factored form of the denominator and say that it cannot be equal to 0. Then separately deal with each factor. X cannot be equal to 0, and the x minus y cannot be equal to 0. In the second case, you can add y to both sides, discovering that x cannot be equal to y. On the right side of the screen, I'm going to write the answer to the problem. X plus y over x minus y, comma, now the restricted values. We've discovered that x can't be 0, and that x cannot be equal to y. All right, and finally, number 27. The top is a difference of squares. It's going to factor as r plus s and r minus s. The bottom is a trinomial. Now, to make 4r squared, it could be 2r and 2r, but if it turned out to be that, there wouldn't be any canceling. So it's more likely that it's 4r and 1r. Now, to make the -5s squared, it's got to be a 5 and a 1. One's positive, one's negative. There's also going to be an s by them. Because the middle term has a +1, I want the larger product between my outer and inner to end up being positive. So I'm going to put plus 5s here and minus 1s here. The reason I did that is so that my outer product is -4rs and my inner product is +5rs. And when you add these together, you get 1rs, which is what's in the middle. The next step is the canceling. The r minus s cancels the r minus s. And so the final result has r plus s in top, and in the bottom has 4r plus 5s. Now the restrictions. So the denominator in its factored form is 4r plus 5s times r minus s. And that can't be 0. Now let's investigate each factor separately. So 4r plus 5s can't be 0. And the other one is that r minus s can't be 0. If I subtract 5s from both sides, I get 4r cannot be equal to negative 5s. And then if I divide by 4 on both sides, I get that r cannot be equal to negative 5s over 4. In our second situation, if I add s to both sides, I discover that r cannot be equal to s. Okay, final answer I'm going to do in the bottom middle of the screen because I have more room there. It is r plus s over 4r plus 5s, comma, now come the restrictions. R cannot be equal to negative 5/4 s, or r cannot be equal just to s. This concludes the solution guide to the assignment.